Can we can we please welcome you with the reaction of clap? So you are welcome, sir. It's such an honor to have you among us this evening. You have the floor, sir, Mr. Olawale.
Hello, everyone. Thank you for this opportunity to be able to present today. I want to appreciate the person who introduced me. Thank you, Mr. Peter. And I want to appreciate Prof. Olawale Awe for this opportunity to be able to share some things with people here today. Um, so what I'm going to do is that it's going to be in two parts. The first part is that I'm going to talk to you and present to you the slides. And then we're going to use, after that, then we'll launch into the R session and we'll pick it up from there. So mind you, I just want to inform you up front, some things we might be talking about today is not just introductory. I know the session is introduction to R for data analytics, but then we might touch on some things that a little bit above introduction. But then if in the process of we doing it, you'd have question, you could just type it in the chat or indicate by the raise of hand virtually to ask your question. Um, and then you could as well type it in the chat if you have any question. So just hold on. Let me get my slide. Let me share my screen. Um, please confirm if you can see my screen. Can you see my screen? I would appreciate if somebody can just unmute and confirm for me that you can see my screen.
Yes, I can see your screen, sir.
Oh, thank you very much for the confirmation. Yeah, so I'm going to talk to you, introduce you to R. Some of you might have used R before, but if you have not used R before, that is fine too. So R is actually a programming language. Most of you might have heard about Python. Python is a programming language. R is also a programming language. However, R is majorly or mostly statistically focused. So if you are working on your research data and you want to do your analysis, and most of the component is statistical based analysis, R is a good tool for you to make use of. So what is R? R is a powerful open source programming language designed specifically for statistical computing and graphics, right? So R has its own graphics, which is you can use it for. And also there are thousands of packages available through CRAN. So CRAN is Comprehensive R Archive Network. It offers solutions for virtually any data analysis challenge you might face. So R is a good tool you should learn if you have not learned it before. So the question is, what is R Studio? Because you might have heard about R and R Studio and be wondering what is the difference between R and R Studio. So R Studio is actually the lead integrated development environment. It's an IDE. So basically you can work with R using R Studio, right? So it transforms R from command line tool into a comprehensive workspace. It provides simplified coding, visual tools. So the thing is, if you run your codes in R Studio, the way it's displayed visually is more visually appealing than base R. So, and also you could use it for project management, organize script, data, and output in structured project. So basically, so you have the R Studio interface overview. You have the source or the script editor. So in R Studio, you have a place where you could run your script. And also you have the console. So you have the console, that's where the R commands are being executed. And you have the environment, that's where you have the history, the environment or history, that's where you can view your loaded data object, the variables, and you could track your command history. And as well, you have files or plots or packages help. And by the time I'm going to actually show you my R Studio so you could see. And so in that place, that fourth section is where you could navigate files, view visualizations, and you can manage packages and access documentation. So an example of code you could run in R is that is what you have there. So if you look at this, so basically in programming languages, you could have what we call comment. For R, the way we comment a line of code is what we use is that hash symbol, this hash symbol. You use it to comment a line of code. So basically, when you comment a line of code, what you do in essence is that that code is not going to run as part of your other codes. So, but if you uncomment it, then you'll be able to run it. So the word comment is that you just want to maybe note something there. So if you have a code you don't want to run as part of the other part of the code, you could use the hash symbol. And we use this less than and this like a minus sign. The combination of them, that operator, it assigns values to variables. So the comment is with hash, and this symbol, this operator, it assigns values to the variables. And if you want to run the line of code in R, you could use enter. You could use Control plus enter on your keyboard. Yeah, that is if you are using Windows. So if you are using Windows, you could use Control plus enter. And if you are using Mac, you could use CMD and then you could use enter. So the combination of both, you can use it as a shortcut for running your code. So also usually in R, we make use of packages. So packages extend R's functionality with specialized tools and functions. So if you want to install a package in R, what you can do is to use install.packages and you put in bracket with this inverted commas and then you put that package name. So for instance, this one, the package name is tidyverse. So you could use it to install. So basically you need to install your package before you run the library, right? So after you've installed the package, then you can run the library. What the library does is that it activates the package for current R session. So that's what the library does. So the tidyverse is a popular collection of packages for data manipulation, visualization, and analysis, right? So ensure so there are other packages actually, but this is just as an instance. So you could also load built-in data sets. So R actually has built-in data sets. The data set that they're actually built into R. So for instance, the empty cars data set. So R includes some simple data set like empty cars. And so when you use add, this add function, it shows you the first 6 rows of the data set. This add function shows you the first 6 rows of the data set. And you could use the summary function as well to check just a quick understanding of your data of the minimum, the maximum, the mean, the median, the cutouts for each variables, right? So if you want to use, you could use a summary to check that. So you could also use, you could also create basic plots. You could use the plot function. Mind you, RStudio has its own, you could visualize data using RStudio. So if you want to visualize the data, you could use the plot function to visualize it. So the X and Y variables define the axis. And yeah, you could also use ggplot2 for data visualization. So ggplot2 is also a package in R that RStudio that you could use for advanced visualization. You could use that. So this is where I'm gonna end it for now for the presentation. And what I'm gonna do now is to stop sharing. So I want to ask at this point in time, does anybody have a question to ask? Or rather, let's do it this way. So what I'm going to do, let me just go ahead and share some things to discuss with you in RStudio. Then after that, when you have questions, you could ask your question after that. So just give me a moment to share that. Okay. So I'm now, so this is the interface. This is my RStudio interface. You will see it's like divided into these major sections, this 1, 2, 3, and 4. So if you want to see your plot, you'll see it on this end, this particular end. Those variables you have loaded, you will see them here at this place, the environment or history. And then if you want to type in maybe your code, this is the editor, and the console for running your code. I mean, which shows that the code that has run is this place. So this is the console. And this plot portion is where you have the editor, right? So now let's start. So the first thing first that I would advise you to do actually when you want to use RStudio and you want to run your data analysis is to first check the working directory. So what is working directory? So working directory is where your R is working from, like where it picks the data from. If you don't set your working directory and you use a wrong working directory, R will not be able to fetch your data. So that's why you should be able to set your working directory correctly so that R can fetch your data where your data is. So first thing first is to get to know currently where is my RStudio working from. So what you could do is to run getwd. Remember, if you want to run the code, there's a shortcut to running the code. Can anybody tell me what the command is to run a line of code in R? Anybody? What is the shortcut? I actually mentioned it during the presentation.
Enter.
You said what?
Enter.
Control plus enter. Thank you very much. So you use control plus enter. Now, if you look at my console, you will see what the result is. You will see where I am currently working from. So this is my working directory. And actually, that is where my data is, right? The specific data I want to use for my ANOVA, that is where it is in that folder. So yours, if this is not the working directory, what you could do is to set the working directory. So if you have, let's say you have set working directory, so what you can do is you go to your file, where your file is. Let me see. So you go to your file. Let me see. So what I'm going to do is that you confirm for me if you could check, if you could see where my file is. Can you see?
Olaniyan, downloads video.
Yes, thank you. Now, however, what I was asking is I've actually opened the folder. My folder is actually opened already. So there's a folder that is currently open with a data set named blood_serum. Can you see that? Is that displaying at your end?
No.
No,
It's
sir.
not. Okay. Just hold on. So I'm going to share so that I want you to be able to run. I want you to be able to get how to do it in case. So can you see it now?
Yes.
Yes, please.
Good. Thank you for the confirmation. So you look for where that data is, and then you right click on the data, and then you go to, you can check for more information, and then you go to properties. So for these properties, you could just get, so look at my own, this is my own location. So you could copy this. Once you copy this file, then you could then paste it into this and put this double inverted comma and put it inside. So once you put it inside, just change this direction, this symbol, this slash symbol, backward slash symbol to the front type. So once you do that, then you can press Control Enter. So can you see it has run? So in case your working directory is not set, what you can do is that you could set the working directory and do that. Okay. So what we do basically is that we'll do just basic start stuffs, and then we'll do ANOVA, and we'll do survival analysis. And after that, you could ask me question, and yes. So first, so here what I want to do is that I want to assign these values into steps. So my variable name here is steps, right? So I'm assigning these values 3,000, 4,000, 5,000, 6,000, 7,000. I'm assigning them to steps. So after assigning them, I want to check actually, for me to check the length, what I need to do is to use the length function. So length steps is going to tell me is 5. And also, if you want to check for the sum, the addition of everything is to use the sum function. And then if you want to check for the mean, you can use the mean function. I'm not going to dwell too much on this aspect. Does anybody have a question? Please, if you have a question, you could just suspend it until the time for question and answers. So I'm not going to dwell too much on this aspect, but just to give you an introductory start. Some of you, maybe you have used R Studio before, fine. But if you have not used it before, these are some basic things you could do. In fact, you could use R as like a calculator. Let me give you an instance. For instance, let's say I assign A to 6 and assign B to 7, right? To 7. So, and let's say I want to add the two of them together. You could just do A plus B, right? And run it. So, sorry, you see that it says object A not found. Do you know why? Can anybody tell me why it says object A not found? Anybody? Because I've not yet run it. So you should make sure you run them before you. Can you now see the result? What's the answer? Can you see this, my console?
Yes, please, you can.
So what's the answer?
13.
Yeah, 13. 13. So always, it gave me error because I just run this without having to specify to R what the A value is and the B value is. So I just went ahead to run this. So be mindful of that. Before you run a code, make sure you've run the previous code that relates to that subsequent code that you want to run. So so you could use it for multiplication too. So if you use it for multiplication, you could see that the result is 42. So please, can we keep mute, please? So you could as well check the first value. The first value here is 3,000. So I use steps 1. It gave me 3,000. The step 3, it gave me 5,000. 5,000. And then so if you want to check the second and the fourth, so the second is 4,000, the fourth is 6,000. You could check using that. So I'm not gonna dwell much on that. Let's go to analysis of variance. ANOVA, analysis of variance. So the first thing first is to read your data into R. Read your data into R Studio. So you use this function, data, and you assign it to read.csv. So the data set I'm working on here is a CSV file. So you use your read.csv, and the name of the data set is blood serum. So this blood serum is actually a data set name that is in the folder, the ADA folder, blood serum. So what you do is you could run that, and so that is stored inside data. If you want to check the structure or just some things about the data set, you have patient, cell, serum, and growth. So it gives you indication of the variables in that data set. So those variable names, they are listed there, and you could as well check the summary of the data. So for the patient, it's going to give you the values, the minimum and the likes. Then the cell variable is on the serum and the growth. So now what we can do is that, so for the cell, you will see that the cell is character, right? If you check this, the cell is actually character. And for us to use the data set for ANOVA, for analysis of variance, we want to be able to specify the cell variable as categorical variable, right? So what we do is that we use this as.factor function, and then our data set name is data, right? And we want to put the cell variable to be categorical. So we can run that. So we use this as function to be able to specify to R that this want to specify it to be categorical, and also to use their analysis of variance. We have the AOV function for analysis of variance. So what this does is that it models the growth variable to the cell variable, right? It models the growth variable as the response. So your response variable is here, and your explanatory variable is here, right? So for those who may not be familiar with response variable, that is the outcome, right? So this is the outcome, and the cell is the independent variable, the X variable. So we run this. So after running this, we need to now use the summary function to check that. So if we check this, I just hope you're able to see it. This annotates. Okay, yeah, I can move it. So Okay. So just if you look at this result, the summary, you'll see that the sums of square for the cell variable is 0.003, the mean square is 0.0034. And if you look at the probability, you will see that the probability is more than 0.05. And these are the residuals, the degree of freedom, and the sum of squares and the mean square. So if you also want to check, let's see if we could have a plot to just show something. So for this one, yeah, we already have this. So let's also make the serum to be categorical to the S factor. Then, so in ANOVA, analysis of variance, we have different types. We can be one way, two way, and so we have other types of design. It can be Latin square design, and so there are different types of analysis of variance. So here, let's also run a two-way analysis of variance too. So here we are using two explanatory variables, the cell and the serum, And let's find the summary. So this is the summary. So the cell variable, you have the summary for it, the serum, you have the summary for it, and the interaction of the cell and the serum, you have the result for it. So let's check for the box plot. Okay. So if you look at this box plot, so box plot there are different parts to the box plot. You have the minimum. So this line is your minimum, right? You have the first quartile. This line is your first quartile, right? You have the median, then you have the third quartile and the maximum. So basically for LN cap after, the maximum is 3.0. And so for each of them, you have the respective output there. Now, basically, what this suggests to you is that you could actually make some result or some answers or some outputs from these and make some interpretation rather from these. Basically, first you can establish that there is significant difference between these four categories, right? Between these four categories. Now, if you want to check the description, so actually, maybe I might talk about that when we get to the survival analysis aspect. What you can establish here is that there may be these significant differences among these four categories of the serum, of the cell and the serum. And then also you could tell that the one that has the maximum growth is the one with NIH 333 dot after this one. Is the one that has the maximum growth. Now, you could as well do two-way, you could as well do two key test analysis. So what that does is that you want to check significant difference, which of the two categories are actually significantly different. Yeah, you could establish that the four of them are significantly different, but which of the two pairs, if you want to take them in two pairs, which of them can we say are the specific significant difference? Now, if you look at this one, you will see that the p-value of serum is 0.0431, which has significant impact on the growth, the serum. So that suggests that. So you could do the two-key HSD test and the likes, but we can just skip that. So moving on to the survival analysis. So for survival analysis, we have some packages we could use. You could use survivor package. There's another one, I believe it's Subminer. You could use that too. But here, for this purpose, we'll be using survivor package, right? So what you can do is that if you want to get this package at your end, you could just use install.packages, right? And after that, you could just put what you want to do, right? So, but I have the package already. So in your case, if you want to install the package, you could use install the packages survivor, and then you could use library, and you put survivor, right? So survivor. But since I have survivor there already, I can just go ahead to call the data. So I have this. So that function gives you different data sets in the survivor package. So we have AML, bladder, and the likes. We have other data types, other data in the survivor package. So, but specifically, I'll be focusing on the cancer data. the cancer data. I'll be focusing on the cancer data, this one. So I'll be focusing on this cancer data. So you have the data. Once you have all the data, add. So what does add does? What does it do? It shows you the first 6 rows in the data set. So if you look at the first 6 rows, you have the variable names here. And if you are not sure what those variable names stands for, you can use this question mark cancer to check. You could just check. So if you check that, it's going to give you the description of the data set. So NCCTG lung cancer data. So you could check this INST is institutional code. And so if you want to check more about what each of the variable names stands for, you could check their names here. So now let's recode the cancer status data. If you check, if you want to record the cancer scars, we could use this. And if we run, so some of you, I don't know, I guess some of you might not have used survival analysis before, right? So basically, before I proceed, let me just talk a little bit about survival analysis. So survival analysis actually is a procedure whereby you want to measure the time to event of a particular issue. So for instance, let's say you want to measure the time to event that somebody dies, right? The time to an event, right? That's when you use survival analysis. So, and in survival analysis, we have sometimes in the process, let's say some things happen, or let's say you want to conduct a study whereby like an infection occurs, and in the process, the people you are studying, maybe some people they left the study in the process. Those people, you take them as a censor, right? Those people they are censored, right? So if you want to run that in R, I mean, you could take your time to study more about survival analysis at your own time. So, but for this, we could just mention of some things here. So if you want to run the survival, we have this function that is soft fit. This soft fit. So we have what we call the Kaplan-Meier survival curve. And I'm going to display the curve to you using RStudio so that you could have an idea as to how the survival curve looks like. Kaplan-Meier survival curve. Usually that curve is stepwise, right? So, but let's fit the model first. So we use this soft fit function to fit the model. And this is the response, the survival object, and we have the sex. So if I run that, so let me plot it for you to see the Kaplan-Meier. Yeah. So this is a Kaplan-Meier survival for lung cancer patients using this data set. Now, these dotted red lines, they represent the one for female, and the one for the blue line is for the male. What that suggests is that the female, they have higher survival probability than the male counterpart, right? So that is what that suggests for the Kaplan-Meier survival curve. So basically what I'm going to do is that at this point, I'm going to stop. I'm going to stop sharing my screen. So at this point in time, what we will do is to take a question, or better still, if I could just give you the data set, or give you a link where you could get the data set, data set I used for the serum, right, the blood serum. So hold on, I would like you to get the data set. After you get the data set, I want you to I want you to just type it in the chat and tell me, just hold on. Yeah, just tell me after you've been able to get the data set. So I want you to do that. But while you are doing that, I want to give room for a question. You can as well type it in the chat box if you have a question based on what we have done. And if you don't have a question, just go ahead and download the data set. Once you download the data set, type it in the chat, just put downloaded. I will then get something for you to practice with. But just let me know after you've been able to download the data set. You can just put downloaded. in the chat. CSV file, the CSV file. From those greater than sign, they are from the console.
Okay, so it's not needed in the
It's
editor.
not needed again. So yeah,
Okay.
yeah.
I just want to copy it and run all at once, so that it
Okay.
doesn't take too much time. So the outputs are usually on the console, right? Okay, so
Yeah.
was it like you moved your own console to this part? Because the outputs were coming out here, like or something.
No, my console is also like towards the left downward
Left-hand
part.
side.
Is the plot that you saw on the right
Okay,
down part.
okay.
Yeah. So
Nice.
yeah, so
Okay.
then you should be able to save it. So
Thank you,
thank
sir.
you everyone for joining this session today. If you want to learn more, you could continue with us at Awesome Data Academy, and you could, if you have further inquiry as to what you could do to learn more, you could reach out. Thank you very much, everyone. Have a nice day. I'm gonna stop speaking here. Thank you.
Thank you very much, sir.
Oh, thank you very much, Mr. Olawale. Please let's appreciate our speaker. He has done so well for us today. Let's appreciate him. Thank you very much for joining this section. Right, I believe we have been able to learn one or two. And if you want to continue with our programming, you could pick up this course at Awesome Data Academy. I'll be dropping the link to our website. Peradventure you would want to register for this course and continue with it. I'll be dropping the link right now.